Welcome to the ET335 Logic Circuit Design and DeMorgan's Theory Lab presentation. Okay, we're going to design an auto burglar alarm in our PLD. Okay, and we're going to build a truth table. And the one thing we're going to add that we haven't used before is don't care down here. So, okay, let's go ahead and start. So if our ignition is on, we don't want our horn on any condition. So X means we don't care. We could be windows up, down, we don't care, and the horn's going to be off. So if we're driving, we don't want alarm. Okay. If our switch is off, we don't care, and we certainly don't want our horn going off. Okay. So now let's see what happens. So if we have ignition off, if we have our switch on, and let's say somebody tampered with our door and our window's okay, so we're going to get a horn. Okay, so our ignition's off, our switch is on, somebody tampered with our window, we're going to get a horn. Okay, ignition off, alarm switch on, somebody's really mean and tampered with our door and window. So we should get an alarm. Okay? So if our switch is on, ignition is off, and our car is safe, no window, no door tampering, and we're not going to get an alarm. So that's our basic truth table, and what we need to do is we're going to convert that to a logic circuit. So I'm going to give you a little hint here, and then I'll do something on multisim. So when we have a one or the other or both, what does that sound like? That's an OR gate, right? So our window and door would best to be an OR gate. Okay, and you could go through and do this as a logic circuit, but my suggestion is this is a control gate problem. So our ignition and our alarm switch are both control gates. Okay, so these should have one input and then one input for a switch, and that should disable our alarm or enable our alarm. So ignition and switch should be a control gate, either an AND or an OR. And probably the easiest thing to do would be an AND. That makes a real good control gate. And our door window input should be an OR or an OR. And that should help you with the circuit design. Okay, we have our multisim open, and I'm not going to design the whole alarm system for you, but I'm going to give you some hints. Okay, the first thing let's do is let's build our inputs. So we're going to go to our switches in BASIC, and we're going to find switch, BASIC, switch, and we're going back to our SPDT, single pole double throw. Alright, so that's going to be our switch of choice here. So let's go ahead and flip him horizontally, and I'm going to grab ground. Let's go to power sources, ground, and let's grab VCC. It's a logic circuit, so let's make it to 5 volt. Okay, so this is our input switch, and I'm going to go ahead and go to TTL, and I'm just going to grab an OR gate 7432. We're definitely going to have an OR gate. I'm not going to do it for you, but here's our OR gate. Okay, cancel. So let's make this larger here. Zoom area. There we go. And let's grab an AND gate, because that would make a real good gate for our control gate. Alright, 7408. Alright, so I'm going to show you how to do a switch here. Alright, let's grab a probe. Go to indicators, probe. Red, that would be a good alarm color. Okay. And I'm going to grab a clock because let's go ahead. He's going to be our flasher, but I'm going to demonstrate something. So let's go to our sources, signal sources, and let's go to a clock voltage. We're going to use him as a flasher demo. Let's get him out of the way, grab a ground. Okay, so let's move them down a smidge. Move them back upwards. Yeah, that'll be good here. Let's go ahead and use our top one is going to be our control gate. And let's take our little flasher here. Okay. I'm not gonna. Okay. So let's go and turn it on, and that's way too fast for humans, so we're going to slow him down. I'm going to put 5. That seems to be a good. Okay, get a little warning here. Let's turn it off and turn it on, and now it's flashing. So I have a high in to an and, so that means anytime this is high, it's going to go through. That's our control gate. So let me just say this may be our ignition or our alarm switch. So if I go to space, I'm going to turn it off. That's our control gate. So if I want to turn something on and off, I'm going to go ahead and use a control gate. In this case, an AND works really well. Okay, let's go ahead and assume that this would be our ignition switch. And let's say that I want it to be off and I want it to be high over. What am I going to do? Let's go ahead and just put an inverter in it. So you can make this key either on or off and still control our gate. Alright, so we're going to end up with 2 control gates and some kind of a logic which is going to analyze our windows and doors. Okay, so we're going to have our final gate, and then we're going to add this kind of arrangement with this clock so we could get the flasher. So the first one we just want to put the LED on, and then the last one we want to put our flasher. So that should be enough to get you started. Okay, I'm going to do this problem for you. It's a DeMorgan problem, and what we have here is a circuit, and we're going to go through and demorganize it and convert it to gates that we have in our kit. And first thing we're going to do is, what is a bubble input NOR, or AND? So what we're going to do is change the symbol, push the bubble. So this guy is going to become a NOR. This guy he's okay. We have NAND gates in our kit. What about this guy? Well, it's also going to become a NOR. Alright, this inverter's fine. Don't cancel these out, otherwise we're not going to be able to do that. So we're going to have this inverter into our OR. And this guy, again, let's demorganize. Let's change the symbol, push the bubbles, so we have a NAND. So those are all available in our kits and on multi-sim. So we're going to build this demorganized circuit in multi-sim and see what the output would be.